Okay, now we are looking at objective number 16 in Algebra 1 called graphing lines. So we have 6 equations here, and we need to graph the lines that are associated with those equations. So first of all, let's look at number 12 here. Y equals 2 over 3 times x minus 1. So the easiest way to graph this equation is to recognize that this equation is in slope-intercept form. So 2/3 is the slope, which is our rise over run, and our y-intercept is -1. So the quickest way to graph this is to first of all lay down the y-intercept, plot that. So starting at the origin here, we're going to go down 1, put our y-intercept there, and then from the y-intercept we're going to rise 2, run 3, and lay down another point. And then we can lay down a couple more points. So if we rise -2, run -3, we'll find another point on the line. Okay, so we have 3 points there, and then it's easy enough to connect them with a line. Okay, so there's the graph for number 12. Now let's look at number 13. Y equals -2. Now here, this is also in slope-intercept form, but there is no x. That means that the number multiplying the x is 0, okay? So the slope of this line is 0. The y-intercept is -2. So we have a point down here. Now many of you just left it at that. You just drew the y-intercept at -2, and then that's it. But we have to realize that this equation, when we have a two-dimensional grid, is a line, okay? So all of the points that have a y value of -2 lie along this horizontal line. Okay, so that is the graph of this equation. It's a horizontal line. Now let's look at this one. Here, this is also written in slope-intercept form. The slope is -2.5, but let's write that as a fraction. Okay, if we can write the slope as a fraction, then it will be easy to find the rise over run. So we're going to do that in the calculator. -2.5, and then we're going to convert that into a fraction. Menu, number, approximate to fraction, -5/2. -5/2 is our rise over run. Our y-intercept is +1. Okay, so let's plot the y-intercept again. So starting at the middle, we're going to go up 1, plot a point. Now our rise is -5. 1, 2, 3, 4, 5. Our run is +2. 1, 2. Bada bing. So we have a second point. So let's connect those. Okay, so our line looks something like that. Alright, now let's look at number 15. 3x minus y equals 0. Now this is written in standard form, okay? But we need to write it in slope-intercept form in order to easily graph it. So this means that we have to solve it for y. So the first thing that we need to do in order to solve this equation for y is to move the 3x to the other side. To do that, we're going to subtract 3x from both sides. So -y is left over on the left equals 0 minus 3x is just -3x. Okay? Now, in order to make this into a positive y, we have to multiply both sides by -1. Okay? So basically, we just change the sign of the y and change the sign of the -3x. So this becomes +3x. Okay? So now this is written in proper slope-intercept form. Now the slope is +3, which written as a fraction is 3/1. The y-intercept is 0. Okay, so y-intercept, we're going to plot that first, as always. 0. Okay, so the line is going to cross the y-axis right smack in the middle, and then the slope is 3/1. So we're going to rise 3, run 1. And we can do the same thing. We can rise -3, run -1 and plot another point on the line. So our line is going to look like this. Bada bing. Now, let's do the same exact thing with number 16. We need to write it in slope-intercept form because currently it is in standard form. The x and the y are both on the same side. So let's move them to opposite sides and solve for y. So we're going to add 5x to both sides now. So 2y is equal to 5x plus 4. And now I'm going to divide both sides by 2. So y equals, over here we have 5x over 2, which I'm going to write that as 5 over 2 times x, and then 4 over 2. I'm going to add that, so 4 over 2 is just 2. So it's easy enough to see that the y-intercept is positive 2. I'm going to plot that down right here. And then rise 5, run 2. Well, we kind of run off the grid here, so I'm going to go in the opposite direction. I'm going to make the rise and the run negative, both of them. So I'm going to rise down 5, run negative 2. Okay? So notice that the line still has a positive slope. And if we, for example, start at this point, we would rise positive 5, run positive 2. Okay? So that is the graph of that equation. Now let's look at number 17. Now number 17, if you wanted to, you could write this in slope-intercept form. Actually, well, we'll do that in a second, but I want you to notice that this is written in point-slope form. Point-slope form. So we can immediately see that a point on the line is 2, comma, -1. Okay? If you remember point-slope form, you can easily extract a point that's on the line. And then our slope is -3. Okay? So we're going to plot this point, 2, comma, -1, so 2, -1, and then our slope is -3. So we're going to go down 3, over to the right 1. And then we can do the same exact thing except go in the opposite direction, like that, and then like that. Okay? So our line looks like this. Now, if you wanted to, a foolproof way of doing this is to write it in slope-intercept form. Okay? So let's just double check our work. So we're going to distribute the -3 into the parentheses. So y plus 1 equals -3 times x. -3 times -2 is positive 6. And then we're going to subtract 1 from both sides to solve it for y. So y equals -3x. 6 minus 1 is 5. And there we go. We can see that the y-intercept is indeed positive 5 when it's written in slope-intercept form. Okay? So this objective was not too bad at all. Graphing is a very useful skill, so I hope that this came naturally to you because it's so important and relatively straightforward to do. Right? The goal is simply to write the equation that you want to graph in slope-intercept form by solving for y. Okay? And that is it.